So today we are going to study the maximum minimum value problem. Okay, there are some quantity. Depending on a quadratic function. Therefore, we can talk about maximum value, minimum value of the problem. Okay. I begin with the following. Okay. So first of all, we know the graph of how does the graph look like a quadratic function. A graph of quadratic function is going to be parabola. So it depends if it's open upward, downward. If it's open upward, then it has a minimum value. If it's open downward, it have a maximum value. So I begin with a function, a quantity, right? So if we have a function, a quadratic function, it's going to be minus 2x plus 3, for example. I begin with this problem, okay? So this function, you can quickly express it in the form like that. Okay, let's look at, this is a standard form. Okay, that's the first general form. Why we have to study standard form, right? We will see that. Now, then you consider the equation, the corresponding equation, which is going to be now x minus 1 squared plus 2. We know that the graph of this equation will be a curve. It opens upward, okay? So when x increases, y value increases. So it's increases from both sides, negative infinity, positive infinity, let's go all the way to top, okay? But from this picture, you will see the couple things, okay? When x equals 1, y is going to be 2, right? Because when you plug 1 for x, you get 2. And you also, that's the first thing. So the point 1 and 2 is on the graph, okay? Then you also see that for any values of x, y equals x minus 1 plus 2, never be less than 2. It's always greater than or equal to 0 square 0 plus 2, right? So it's always greater than 2. So that means the smallest possible value for the y is going to be 2, right? So that means the graph is always above, the y value is always greater than 2. So it's actually, this is a graph, okay? This is a graph, okay? So 2 is going to be the minimum value, the smallest value, okay, of this function f of x, okay. Yeah, that is a, and when you look at this graph, because the graph is open upward, and it does not have an x-intercept, so clearly there is no roots for this function, no x-interception here. But you can also find out what is that number. That number is going to be 3, okay? Because when x equals 0, it's negative 1 squared plus 2, so it's going to be 3, okay? So that is a, so I use the example to talk about, discuss, to find the, yeah, to let's understand the graph and the minimum value, maximum value, okay? If the graph is open upward, then it's clearly there's the lowest point that gives you the minimum value of the function. So now let's look at the next problem, okay? Given this function, okay, what is minimum value? What is the extreme value? Okay, this could be maximum, could be minimum. what is the extreme value for this function. Okay. Now, how can I sketch the graph? Because the function is going to be, if you multiply this out, it's going to be negative x squared plus 27x. Okay. There are a couple ways to understand this problem. One is you express the function in the standard form. Later on, I can tell you the shortcut. Okay. So you take negative sign out, right? And you complete the square, so you have to plus half of 27 square and subtract half of 27 square. Okay, then this will be combined into a square. Okay, this will be combined to the square, so it will be negative x minus 27 square minus. Okay, now if you multiply this out, all right. So, but if you look at this function, the expression of this function in the standard form, this never be positive. So it's always less than or equal to 27 over 2 squared, right? So this is going to be the maximum value of the function. So you find the value function after you rewrite this expression. You don't need to see the graph. Okay. So this is the maximum value. Yeah. But you have to express it in the standard form. Okay, that's a standard form. Okay. So I'm go back to this function again. This is a very special form. So from here, you will see that if I let y to be f of x, then I just need to find the maximum value for y, right? So I know that when x equals 0, y is 0. Okay, good. But also it's easy to see that when x equals 27, y is also 0. What does that mean? So you get two x-intercepts, okay, of the parabola. I know the graph is a parabola. It's passing through one point, another point, 27. But I know the leading coefficient is negative. So that means the graph opens downward, okay? So why opens downward? Because the leading coefficient is negative. All right, since the parabola has a special property, it's a symmetric about the middle line. So clearly, somewhere in the middle, the graph has a highest point, okay? So that number should be, here's half of that, right? This is where half from. So at that point, by the symmetry, of a parabola, okay? So using the graph to solve the problem here, not algebra. I know the graph is parabola. So parabola is symmetric about the axis, okay? So using that, I can quickly find out the middle point. Then the y equals the maximum value at x over 20 at 27 over 2. Okay. So what is that value? The maximum value is going to be 27 over 2 times 27 minus 27. Okay. So just 27 squared. 27 over 2 squared, the same number, right? All right. You don't understand this? All right. So yeah, quadratic function is different from linear function. Okay, in general, we go back to the problem. Yeah, in general, if you have the function in the form like that, okay, here's a is not equal to b 0. Okay, so let's summarize. So you can express it in the standard form. Okay, and you can always, that's a standard form. Okay, we learned how to express it in standard form in the last class. So you did some homework, you should know that. All right, then you consider the corresponding equation. Equation, you need two variables. Okay, this is the corresponding equation. More details is y equals ax minus h squared plus k. And we know that the graph is going to be the graph of this equation, okay? Yeah, that. This is going to be, it is a parabola. It's called a parabola. It always goes like that. It depends on, was a parabola with a vertex, h and k, okay? So here's h and k, it looks like that. Either this one depends on the sign of a, okay? If a is positive, it's open upward. If the sign is negative, opens downward, okay? So then you can see when the function has maximum value and minimum value. So that's a summary of the whole theory, okay? And why this point, the vertex h and k? Because k is going to be the extreme value. Of the function, either it has a maximum value or the minimum, depends on the sign of a, depends on the graph. Okay, I'm going to go back to the problem again. Okay, so given the function x squared plus 4x plus 1. Okay, let's do this. Look at this. All right, find the extreme value. Okay, how do you do that? Yeah, this function cannot be very, forget the 4x plus 1. If it's just x squared, you know that this function never be negative. So 0 is going to be the smallest value. So it has a value, extreme value immediately. Okay, so extreme value means the value can be reached by the function, but there's no number larger than or smaller than that number. Okay, so we have let's express it in the standard form. I think I need a 4 here. Then I have to subtract the 4. Okay, you make it as a square. Okay, so you get x plus 2 squared minus 3. Okay, so this is another form of the quadratic function. The standard form much better. Okay, when you look at the standard form, this never be negative. You agree, right? Because it's always square. So that's why it's always greater than equal to 0 minus 3, which is negative 3. So this is going to be the smallest possible value of the function can get. So this is called the minimum. The minimum value of the function. Okay? So you find the minimum value. So we already get the answer. Once you get a standard form, you get the answer. Now let's look at the graph. Okay? The graph of this equation. Okay? So the graph of this equation, first of all, when x equals negative 2, you get 0, right? So when x equals negative 2, the y value reaches the minimum value, -3. So here's a point, -2, -3. Yeah, this is the minimum value, right? So it has a minimum value, the graph opens upward. Okay? And the y value is always greater than or equal to -3. So it's curved up. Then the axis of the parabola is going to be x equals -2. Okay. Well, from here, can you find the two intersection points with the x-axis? We call it x-intercepts. Okay. You look at the graph. Okay. Now there's three numbers we need to figure out. I put 3 circles here. One is the y-intercept, the intersection point with y-axis. So when x equals 0, y equals 2 squared minus 3 is 1. Okay, so it's 1. So I have to reschedule the graph because it looks like what I did is wrong, right? So it looks like that, not sharper. Okay, so this is the 1. When x equals 0, the y value is 1. So this is going to be the so-called the y-intercept. Right, the y-intercept. Now I want to find this as an x-intercept. How do I find the x-intercept? I set y to be 0. I want to find out the x value. Okay. I use a standard form of the equation. So x plus 2 squared equals 3. Then I get x plus 2 equals plus minus square root of 3. Okay. So I get two solutions. X equals -2 plus minus square root of 3. So both are negative. Okay. No, even if choose a plus sign. So you get two solutions. This is x1, that's x2, and this is -2. So let's understand the picture. Okay, let's understand the picture. So the picture, yeah, let's go back to here. Oops. So this is a -2. And the 2 intersects. So here, the value, the distance between those 2 points is square root of 3. Okay, so -2 plus square root of 3, you get the 1 x-intercept. -3 minus square root of 3, you get another x-intercept. So those are the x-intercept. Okay. Okay. Now sometimes we have to find we know the maximum value. We want to determine the coefficient. So find the value of k such that this function has maximum value of 11. Okay. So what does that mean? So you can change the k value. Okay. But this is a parabola opens downward. Right. Because of leading. Yeah. So we want to find maximum value is 11. So this is above the x-axis. But we don't know where it is. Okay. So you just pretend you already know the equation. So you find the maximum value first, then you set it to be 11. Okay. So what I'm going to do, I'm going to express it in the standard form. Okay. So f of x equals negative x squared minus 3kx. I can put 7 outside. Okay. Then I have to add a half of this 3k over 2 minus 3k over 2 square in order to make the square. Okay. Okay, you multiply this out. Okay, let's simplify it. It's going to be negative x minus 3k over 2 squared plus 3k over 2 squared plus 7. Now this is supposed to be 11. Then you solve it because this is the maximum value. And that's going to be 4, right? And then 3k over 2 should be plus or minus 2. There'll be 2 solutions here, okay? So k is going to be plus minus 3 over 3. Okay. Okay, so you solve it.
7.
Yeah, 3k over 2 equals plus minus 2. Okay. So this is the this is the quadratic. It's called inverse problem.
Dr. Shen, I
Yeah.
don't understand.
Did you do the homework last homework?
I don't think it was like my
Okay, you did not do the last piece of homework, then you forgot how to express it in a standard form. Let's do no problem, okay? So you are given the function equals, for example, 2x squared minus 5x plus 1, okay? Find the extreme value. So you have to express it in the standard form. So let's go over the problem, okay? If we know x squared plus k, okay, then you have to add the half of a k squared, then you get this, okay? K could be plus minus. If it's negative, then they have to put a negative sign here. So that's the identity we use to complete the square, okay? Okay, so this is the identity. So step 1, we needed to express it in the standard form. Okay, if we don't want to use a formula, there's a formula too. So you get 2x, because in the formula, the x squared, the coefficient of x squared is 1. So I have to express in that form. Then I do something for that part. Okay, I needed to complete the square, so I have to add the third term and subtract the same term. Half of 5 over 2 is going to be 5 over 4 squared. Okay, then this 3 will be combining to square. Okay. Then this will be the, then you multiply this out. Okay, and minus 2, 5 over 4 squared plus, well, let's simplify it, okay? So after simplifying, you get a negative number here, the last one. This is 1 minus 25 over 8, I think. Yeah. Then 25 minus 8 will be 7 negative 17 over 8. Okay. Okay. So this is the function you can express in the standard form. And from here, once you get this, I know this is going to be always greater than equal to this. This will be the minimum value. Okay. Yeah, this is the minimum because for no matter what value of x you choose, this expression is always greater than equal to negative 7 over 8. So that is the minimum value. Okay. All right, so my next question is, I know it's a parabola, right, which means the graph of a quadratic function opens upward, right? And I know it passes through the point 2 and 6. We also know the vertex. When the 2, let's determine the equation for the parabola. Find the equation for, okay, for the parabola. Right. So you draw the graph first. So this is the graph. When it's the vertex, when the parabola opens upward, and it passes through another point. Okay. So this is first of all, this is the graph of the function. Now, a quadratic function. But based on the information you get, you already know this is going to be x minus 1 squared plus 2, because that's coming, yeah. That gives you the data you need already, except for the leading coefficient. The leading coefficient A, when A changes, the parabola, the vertex of parabola will not change. Just it's open widely or narrow, when the value A changes. Open downward, upward, because clearly this is open upward, opens upward, okay? So how do you determine the value A? You know the graph passes through point with coordinates 2 and 6. You just needed to plug 2 for x, 6 for y, and you determine the value A. And A is going to be 4, okay? And then you get the equation, and this is the equation for the parabola. Okay. Okay. Now let's talk about applications. Okay, we're going to do some applications. Yeah, where y have to, you see, this is a good application. All right, so a rectangle has a parameter. This is a rectangle. Okay, we know the parameter is going to be 34. There's no restriction. What is the greatest possible area? Okay. Well, based on your experience, you will say that, okay, I know the square has the largest possible area. Then just to find the edge length of the square. Then that's it. 34 divided by 4 will be 17 divided by 2, right? And the square. No, 72. It's not a, it's a prime. Okay. But how do you know the square has the largest possible area? Was a fixed parameter. You don't know. You have to prove it, right? So what you do is, here's the x or y. So equation 1, x plus y is going to be 17, right? It's half of the parameter. And the area is going to be x times y. So x and the y are not arbitrary. X and the y is between, yeah, it's a x and y is a between 0 and yeah, they're relative. The sum is 17. So you can express y in terms of x, so 17 minus x. You set x to be free, then y cannot be arbitrary. All right. All right, so here x is the arbitrary value, but x cannot be negative. Okay, be careful, right? X cannot be negative. So, and x even cannot be larger than 17. So there was a restriction that be careful when you study that. Okay. All right, so now this time the graph, here is A, that's the x. Okay, I'm not going to use the y variable here. It's called the x8 coordinate system. So when x equals 0, A is 0. When x equals 17, A is 0 too. So it's a parabola, opens downward, and this is the problem we discussed before at the very beginning. So it has a maximum value, and when it's happened, when x equals half of 17. Okay, so A equals the maximum value at x equals half of 17, the middle point. Okay. Okay, then we want to find the maximum value of the area. So that is going to be 17 over 2, 17 minus 17 over 2, it's going to be 17 over 2 squared. Okay, so this is the largest possible area you can get when it's a square. Okay, when it is a square. So we not only find the maximum area, we also determine the shape of the rectangle, which has largest possible area. So now, not only just based on experience, now you can use mathematics to prove that square has the largest possible area. Okay, but we have to assume it's a rectangle among all the rectangles. If you can have a freedom to change the shape, if we do not assume it is a rectangle, okay, then the answer will be wrong. Okay, so if it's a free, something like that, if the parameters are fixed, what kind of shape of this region, right, have the largest possible area with a fixed parameter? Okay. Yeah. Then you say, okay, based on my experience, maybe circle, right? So this cannot be proved here. So the largest the circle has the largest possible area with fixed parameter, okay? If you do not assume it's a rectangle, if you assume it's a rectangle, then it must be square. If you do not assume it's a rectangle, then, so suppose you are the builder, right? You want to build houses. If you want to only build houses in rectangular shape, then to save the material, all the houses should be square type of housing. So the material, you put the 4 walls, okay, fixed, then the largest possible area you can get is a square. But for Mongolian, right, for Mongolian people, they find out it's too heavy to carry lots of material moving around, right? So the best way for them to make a house is a circular house, okay? When they stop someplace, stay there for a few weeks, they build a house quickly. Then they want to have a largest possible area with a limited material. Okay? Okay? So remember that if there's no restriction on the shape of the region, then the circle should be the largest area for the fixed parameter. Okay? And maybe you can figure out what is the largest possible. Think about it. If you only consider triangles, among all the triangles with a fixed parameter, okay, what type of triangles have the largest possible area? I guess it's an equilateral triangle gives the largest possible area, but is it possible to prove it? We don't know. It's hard to prove it, okay? And it requires more advanced mathematics. You can think about that, okay? Because how do you express the area? It's challenging, right? You have 3 variables, A, B, C, right? And that should satisfy the triangle inequalities. And how do you find the area of given 3 sides? Well, there's the Heron's formula. So it's not easy. Just among all the triangles, okay, equilateral triangle has the largest possible area. I think the general rule is as long as among all the type, if you fix the type of the shape of the region, the one we call the regular one should have the largest possible area. Okay? If you have 6 sides, then the regular hexagon should give you the largest possible area. Okay? All right, our next question. The sum of 2 positive integers is 27. By the way, the problem I just talked about, the circle has the largest greatest possible value with a fixed parameter. That is one of the problem for the entrance exams to the graduate school in China in 1983. I was a graduate student. I took the test in geometry because my major is geometry. So this is a nationwide test given by the Science Academy of China. And this is one of the problems on the test. I proved that circle has a largest possible area among all the regions with a fixed parameter. That was in 1983. Okay. Okay. The best method they have to prove use a so-called complex analysis. It's an undergraduate course. It's a complex geometry instead of real geometry. So you were wondering why we have to study complex numbers. It's a lot of real numbers. Okay. So the sum of the 2 positive integers is 27. What is the least possible sum of their reciprocal. Okay. All right, let's understand this problem. Now this time the integers, okay, not the regular parameter, regular variable numbers, okay, not the real numbers, integers. That's also important information you should know. Two integers, the sum is 27. We're talking about another sum, which is reciprocal. They're reciprocals. Okay. Among the all, you can, if you have a time, you can list all the possible sums and find the list possible sum. But that takes too much time. So you have to find a way to figure out what is the minimum value. Okay. Find the minimum value of S, right? In other words, you look at the sum, you add them together, okay? You will get, okay, the numerators already know that, 27. All you have to do is find the product of the product of those two numbers. So let's call the P. Okay, we want to find the maximum value. What is the maximum value? If you have maximum value for P, then you get the minimum value for S, right? It's in the denominator. Okay, so P is going to be NM, but the M is going to be 27 over N minus N. So this you get a quadratic function somewhere, but be careful. N is integer, okay? N is 0, 1, 2, all the way to 26. Cannot be 0, okay? So among all the 26 numbers, you are going to find the maximum value. But if you look at the function, let's look at the function. I use the x because x is the arbitrary, can take arbitrary value. So for this one, no restriction on x, just between 0 and 27. You get a graph, opens downward, right? For this function, the maximum value occurs when x equals half of 27, okay? P equals the maximum value when x equals 27, okay, over 2, which is 23.5. But we only consider the integer values, okay? So that means n never, n only takes the integer values. So here is a 23.5, but it's a nearby 23.5. You have two numbers, 23 and 24. So that gives you, this is actually, if you only consider integer value, then the maximum value of the P will be the values at the integers, right? Nearby 23.5. So P equals N 27 minus M. This is going to be the maximum value when N equals 23 and 24. That gives you the same value actually, okay? Which is going to be 23 times 24, okay? Either way, when N equals 24, you get 24 times 23. When N equals 23, you get 23 times 24. And then look at the picture, it's clear, right? Nearby 23, you have two integers. At these two integers, the product has the largest possible value, okay? So this, be careful. There's additional restriction on the variables, then you only can consider integer value, okay?
Aren't those two numbers supposed to add up to 7?
Wait a minute, 23, yeah, sorry. No.
That's 13.
13, sorry, 13. Okay, 13. My computation missed it. All right, 13. Yeah, 13 times 14, yes. All right. Okay, our next application problem is you're going to build yeah, let's say this is the kind of area you can build, right? This is a region. Okay, this side you don't need it. It's a river, for example, right? So you don't need a fence. So this is a rectangular, let's say rectangular garden, something, whatever you call it. So the parameter, the length of the fence is going to be 30 meters. It's fixed. Okay. One side of the region will be a part of the strict river. Okay. So what is the maximum? Yeah, what is the maximum area you can get? Right. What is the largest possible area you can have? And how does it look like? Karen? Yeah, please do the problem.
Does it have to be an integer?
No.
Huh?
No, there's no requirement on the integer.
Oh, okay.
It's a fence, you can bend. You know, some fence you cannot bend it because each piece is about, you know, about consider like a one foot wide. Then you cannot bend that piece. Then must be integer. But here, yeah, here, okay. Yeah, this is a rectangle. Yeah, I said that. All right, so this side called y, that side x. So I know that x plus 2y equals 30, right? And the area is going to be x just x times y. The side different here, right? So now you can use the y variable, you can use the x variable, it really doesn't matter, okay? I can use, it's easier to use y variable because x is going to be 30 minus 2y times y, okay? Okay, so it's going to be 215 minus y. So this is a y-axis, that's x-axis, okay? And clearly, y equals 0, a 0, y equals 15, a equals 0. So it opens downward. And when it has a maximum value for the area, when y equals half of 15, okay? A equals maximum when y equals half of 15, okay? You don't need to get the standard form of a quadratic function to find the maximum value, right? So the area is going to be 2 times 15 minus 15 over 2. 15 over 2, you multiply this out, you get 15 squared divided by 2, okay? Yeah. All right, I'm going to ask you to do the next problem. Okay. Yeah, as long as you see the graph, then you can tell, when it has maximum value. Okay. My next problem is to find the quotient of two integers whose difference is 10 and whose product is as small as possible. All right. All right, so please work on this problem. So you need to basically find those two integers, then you find the quotient. Okay, the reason it's quotient because that sometimes if it's math competition problem, that's only the one number. They don't want you to give it two numbers. Helen? The quotient is not 11. Okay. First of all, the numbers are not necessarily positive. Okay, please work on this. I'll give you, we still have time. Okay, Michael, what do you got? -1. Okay. You have two numbers, right? And let's call it X and Y. So the difference is going to be 10. The product will be the smallest. Okay. No restriction on X. X not needs to be positive or negative. So you will get X, and what is Y? Y is going to be X minus 10. Okay, no restriction on X, but the Y depends on X. So this function, it's a quadratic function, and it is open upward, 0 and 10. Okay, so this P has a minimum value. Okay, P is minimum at X equals 5. Clear? So when X equals 5, P is the minimum. The product is as small as possible. So when X is 5, Y is going to be 5 minus 10, which is -5. So immediately the quotient of the two numbers, X over Y, is going to be -1. Doesn't matter which way. Got it? Good. Okay, my next problem will be find the value of the k such that the line y equals kx intersects the parabola only at one point. Okay, so let me draw the graph. This is a parabola, opens upward. Here you have a bunch of the lines passing through, but there's one particular line will touch this parabola. So I want you to find the value of that k. This is y equals kx. Okay. Now, you just pretended to find the intersection point to solve the problem, okay? So how do you find the intersection point? That's the first equation. Second equation, y equals k. This should have exactly one solution. Because when you have a solution, you get the intersection points, right? The question when it has one solution. Well, there's two equations. So those two equations at least, you will get kx equals x squared plus 1. Okay? So you actually end up with a quadratic equation. And you get 0. Okay? So if this equation has two solutions, you get two intersection points. If this equation has no solution, then it has no intersection point. So you want to get exactly one intersection point, that means this should have a one solution. Okay? This one has one solution if and only if I think it's b squared minus 4ac is 0. Okay, from the quadratic formula. Okay, I will go back to this again. So you get k squared equals 4. So k squared equals 4 and k equals plus minus 2. Okay, why there's two solutions there? Because when k equals negative 2, you have another side, right? Look at that. Now there should have two solutions. Because from the picture, you see that there are two solutions here. Right? One is on the, because there's two lines touches this parabola. The parabola is symmetric. Okay? So that's why you have k equals plus minus 2. Okay. So let me go back to the equation again. Ax squared plus bx plus c, right? And we remember, how do we get the quadratic formula? Okay, so ax squared plus bx plus c, right? So this one, remember, we can derive the formula for so-called quadratic formula. So x is going to be 2a negative b plus minus b squared minus 4ac. That's the general formula, okay? But this formula, it's possible b squared minus 4ac could be negative, okay? Now what does that mean? Okay, this means it has no solution, okay? So when no solution, if b squared minus 4ac less than 0. One solution, if b squared minus 4ac equals 0. Okay, and the two solutions if b squared minus 4ac positive. Now the geometric meaning of this is, if we look at this equation, okay, and this is a parabola opens upward. Like here you have two solutions in this case, okay? And then the first one here has no solution, no intersection. And here you have exactly only one intersection point. Okay, there are three possible three cases here. Okay, so you just need to look at the coefficients, and you can tell the middle point. Actually, the middle point is you can see that it's a plus minus. The middle point is negative b over 2a between those two intersection points, because the solution, if you look at this solution, is negative b over 2a plus minus 2a square b squared minus 4ac. So this will be the middle point between two x-intercepts. And this will be the distance on the picture here, the distance between, because add this number minus this number, you get two intersection points. Okay, so this will be that part. Okay, and yeah, we understand, you know, that we should understand this. This picture here. Okay, so you add, the geometry meaning of this radical square root of b squared minus 4ac is the distance between the middle point and the x-intercept. Okay, and how do we get this? We use we complete a square, and we express it as a standard form, then we get this. Okay, so let's look at the following problem. Okay, if we have kx squared minus 3x plus 3x plus 2k equals 0 has exactly one solution. Okay, what is the value of k? Okay. Okay, now, since you already know the formula, so you just go ahead to find solution. You look at the formula, then you see when you should get only one solution. Okay, so the solution is going to be 2k. Okay, and 2k. You know, be careful about this problem here. We assume k is not equal to 0. Otherwise, you have only one. You probably have more than So we assume that k is not going to be 0 first. Okay, then we analyze it because k could be 0, right? Then that's impossible. You should say that. Okay, so this is going to be negative b plus minus b squared minus 4ac. Okay, so this one, it has only one solution. Really means 9 minus 8k square should be 0. Okay, so k squared equals 9 over 8. K is going to be plus minus 9 over 8. Okay, so you can simplify it, but that's the solution. Now, if k equals 0, what you can tell, the k equals 0 and x is always a solution for any value of k. So don't miss that part. If k is 0, the equation is simplified to negative 3x equals 0. So x equals 0. So k equals 0 is also a solution. Now sometimes you will forget that, right? So this is because when you write down the quadratic formula, you immediately should know that k cannot be 0. Otherwise, this formula cannot be, it's not defined even, right? All right, so you have to look at the case when k is equal to 0. When k equals 0, the equation is the simplest equation, x is 0. So the answer will be k equals 0, k equals a plus or minus square root 9 over 8. Okay, my next question is, let's go over this problem. Okay, find the value of k such that the function f of x squared minus kx plus 7 has a minimum value of 0. Right? So the minimum value should be 0. Yeah, can we do that? It's possible. No, it could be saying no solution, right? So k is there. I know that when k changes, the graph changes a lot. Okay, so can be up, down. Can be open, wide, narrow. That's all change. It's not like fixed. Okay, so you have to justify the value so that the minimum value is 0. If the minimum value is 0, that means the graph touched the axis at one particular point somewhere. You even don't know that point yet. Okay, the minimum value could be -1, but right now, somewhere, somewhere here. Okay, maybe you have 2 solutions. Okay, this is the graph looks like at the end. Okay. Now, to solve the problem, you're just trying to find the minimum value of the function. So you write down the standard form. Okay, x squared minus kx should be plus half of the k squared. Okay, right? Yeah, when you add a number, you have to subtract the same number in order to keep the same function. So this will be x minus k over 2 squared. And here 7 minus half of k squared. Okay. So this function, this is the parabola opens upward. And the smallest value you're going to get is this one. This is the minimum value. Okay. It's a minimum value occurs at x equals half of k. So even that point is also changing. Okay. But clearly when from here, 7 minus half of k squared should be 0, right? So there are two solutions here. Half of a k is going to be plus minus square root of 7, and the k is going to be plus minus 2 square root of 7. Okay, so there are two solutions. One is, I'm surprised, one is at half of k, right? So positive square root of 7, negative square root of 7, so you get 2. Good. All right, so you have two solutions for this particular problem. So suppose you are, it says that it's time, classes. All right, so. Okay, one more problem. We consider the function ax squared plus 2x plus 1. Okay. Find the value of a such that this function has a minimum value of has a minimum value of -1. Okay, let's try. Maybe it has no solution, maybe it has solution. All right, so A could be positive, could be negative. So when we talk about minimum value, minimum, yeah, that means spelling wrong. So A must be positive, right? Otherwise, it doesn't have a minimum value. But we don't know where it's located. Okay, we don't know where it's located. Okay, it's similar to the last problem. Can you finish that? Right? You have a family of curves. I think they all pass through 1. I'm pretty sure this is the pretty sure. Right? I'm looking for the solution that's like that. Okay. So minimum value somewhere. Okay. Right? Why the y-intercept is 1? Because when x equals 0, y equals 1. Clear? Right? This is the y equals f of x, the equation. All right. So what do we have to do? We express in the standard form. Okay. Then then you have a x squared 2ax. I think I have to plus 1 over a squared minus 1 over a squared. Okay. Then you have a 1 over a squared minus, I think this is just 1 over a because a times that is canceled out. Okay. So this part is positive to never be negative. So this will be the minimum value. Now our minimum value should be -1. So 1 minus 1 over a should be -1. And then 2 equals 1/2, 1 over a. So that implies a equals 1/2. It's positive. Okay, it could be no solutions. The reason is that if a is negative, and this graph shows you that a is negative, if I change it to the maximum value, then maximum -1 will never be reached because when you turn up, if it's open downward, the value, the maximum should be greater than 1. So I cannot be -1. It's never be reached. So no solution. But here we just say the minimum value is -1. Then based on our computation, we get solution, one single solution. All right. So that's it. And we are going to work on some math problems in the next 2 classes.